What are reciprocals? Reciprocals are when the numerator becomes a denominator and the denominator becomes a numerator. For instance, 1 over 2 will become 2 over 1. For functions, if the original function is fx equals to ax plus b, the reciprocal will be fx equals to 1 over ax plus b. Now we are going to talk about asymptotes. What are asymptotes? Asymptotes are restrictions of a reciprocal functions. They are vertical asymptotes and horizontal asymptotes. Vertical asymptotes are the restrictions of x, and horizontal asymptotes are the restrictions of y. How do we find the vertical asymptote and the horizontal asymptote of a reciprocal function? For a vertical asymptote, we can use x equals to negative b divided by a. From here, as you can see, the denominator can never be 0. That's why if x equals to negative b divided by a, the denominator will be 0. That is why this is the restriction of x and this is the vertical asymptote of x. And since you know that the numerator is already 1, y can never be 0. That is why the horizontal asymptote is y equals to 0. Here we have an example. If the original function is x plus 1 equals to fx, then the reciprocal function will be 1 over x plus 1 equals to fx. How do we find the vertical asymptotes and the horizontal asymptotes? Just by looking at the graphs. Here's how we do it. We know that the denominator can never be 0, so x plus 1 cannot be 0. So x cannot be negative 1. And therefore we know that the vertical asymptote is x equals to negative 1. Horizontal asymptote, we also know that 1 can never be 0, so y can never be 0. So this is the graph. This is the parent function which is fx equals to x plus 1, and these two are the reciprocals which are fx equals to 1 over x plus 1. Now we see here, now we know that the vertical asymptote is x equals to negative 1. You can see that the reciprocal graph will never touch x minus 1, x equals to negative 1. So it's very close, but it never passes through. And for the horizontal asymptote, the reciprocals do not pass through it as well. From this graph, we can also know that the x-intercept of the parent function is the vertical asymptote of the reciprocal function. Now we head into quadratic functions. The reciprocals of quadratic functions are similar to the linear functions. However, there are a few different cases. Like a quadratic function may have two zeros. That makes it have two restrictions for its reciprocal. For example, 1 over x minus 2 times x plus 3 equals to fx. Its restrictions would be x cannot be negative 3 and x cannot be negative 2. This would make two vertical asymptotes. However, since the numerator is 1, the restrictions for y will be the same and y will never be 0. That makes it horizontal asymptote will be y equals to 0. This is the graph of the original function. X plus 3 times x minus 2 equals to fx. As you can see, this is how the graph looks like, and the minimum point is 0 and negative 6. For the reciprocal graph, this is how it looks like, and you can know that there are two zeros. So there are two vertical asymptotes which are x equals to negative 3 and x equals to 2, and the horizontal asymptote will be y equals to 0. And the local maximum point of this graph would be negative 0.5 and 0.16. Another case is when the quadratic function has zeros that are undefined. For example, this one, fx equals to x squared plus 25. The 0 of x will be root of negative 25. This is undefined. That's why the restrictions of the reciprocal function will be undefined as well. So there are no restrictions on x. It means there are no vertical asymptotes. But however, the same as all the other graphs that are shown, the restrictions of y are still 0. So the horizontal asymptote is still 0. This is the graph of the original function, which is concave up and have a minimum point of y equals to 25. and its reciprocal is concave down and has a maximum of 0.04. How do we know that it's 0.04? We take the minimum point of the parent function and put it into the reciprocal, we will get 0.04. This is how we look for the maximum point for the reciprocal. And there are no zeros, that's why there are no vertical asymptotes. That means x can be any number, but however y is still cannot be 0. That's why the function will never touch the x-axis. The last case is when the quadratic function will have the two same zeros. For example, for this function, the zeros will both be -1. So for the reciprocal function, the restrictions will also both be -1. And the horizontal asymptote will still be the same, which is y equals to 0. Now we look at the graph. The graph has the vertical asymptote of x equals to -1, but the graph extends to both negative infinity x and positive infinity x. And the y-intercept of the graph is 1.